Hello, everyone. Welcome to the Blooms and Beyond podcast, a podcast that uncovers plant history, culture, and management through the lens of science. I'm your host, Ping. How's everyone doing today? I'm doing great because I have one of my colleagues here, Dr. Erich Schoeller, today joining me to talk about the integrated pest management. Along with the line, we are also going to talk about his favorite plant and pest, and of course, some wonderful stories behind the scenes. So I don't want to steal any more thunder from our speaker today. Without further ado, here is my conversation with Dr. Erich Schoeller. I hope you enjoy it. Hello, Dr. Erich Schoeller. Welcome to the podcast. So before we get started with all this wonderful stuff that we're going to talk today, can you tell us a little bit about who you are and what you do?
Sure. Thank you for the invitation. It's great to be here and talk to you today a little bit about IPM. So my name is Erich Schoeller. I'm an assistant professor at the University of Georgia in the Department of Entomology, and my responsibilities are controlled environment agriculture, integrated pest management. And when we say controlled environment agriculture, what we're referring to is crops that are grown under a protected structure, be it high tunnels, greenhouses, or vertical farms.
So there's a fine line with controlling the environment agriculture. We can talk this a little bit more about. Can you tell us, is that something you always wanted to do when you grew up, or it's just something you find through your education or your training or your internship along the way that made you end up in horticulture in entomology specific?
I've actually had a pretty meandering career trajectory in my life. When I first entered undergrad, I actually entered pharmacy school because I wanted to be a pharmacist. Quickly learned that I did not like chemistry, so I changed to a biology degree. For the first couple of years of my undergrad, I was very interested in marine biology. After I did like a 3-week camp in the Bahamas for marine biology, I quickly learned I hated swimming all day. So I wanted to do something land-based and did more of an ecology-focused undergrad. After doing my bachelor's degree, I went to Louisiana State University, where I was in the Department of Entomology there. And for a master's, I worked in forestry, dealing with pests that affect the timber industry. Realizing that I did not like it, having to cut down trees and work in forests around poisonous snakes and horribly high temperatures, I needed something a little more moderate in terms of what I physically was doing. For my PhD, I was at the University of California, Riverside, and there I started doing things that were more similar to what I'm currently doing, which is urban or peri-urban pest management. And there I did biological control of insects that were infesting landscape ornamentals. And then finally, for my postdoc at University of Florida, that's when I really started doing like strictly horticultural production indoors, which is what I continue on into my current position.
Wow, it's amazing to see like from pharmacy to forestry all the way to ornamental, like your trajectory is really kind of give us a hint of how amazing the path to horticulture can be, because I have met so many people throughout the year and people keep telling me how different background they are from, but they all end up in horticulture. So you are definitely just showing us the case. But either from pharmacy, forestry, or ended up in horticulture, we're all dealing with plants, right? So are you growing up with plants, or you're like a little boy loving the little past while you grew up?
Yeah, so I'm grateful that I had a family that really supported nature and my interest in nature. From a very young age, I grew up in a rural sort of surroundings, always out in the country, many acres of land, sometimes forested, sometimes not. But from an early age, I was just outside basically from dawn to dusk and playing in different natural habitats. And I was always just so interested in the insects that were in those habitats. Some of our properties, we had 10, 30, 40 acres, and I would just run through the fields with a sweep net and look and see kind of the things that I was catching in my net as a kid. And so I made insect collections from a very early age and stopped that for a while. But, I had always been very interested in insects from as early as I can remember. And on the plant side, my mom always had beautiful gardens. She was a stay-at-home mom, so she had a lot of extra time, and she would spend that time doing gardening and landscaping, and I would go out there and help her plant various things. So between the plants and
Yeah.
insects, so that's a marriage of what I currently do.
That's perfect. Well, I feel like a lot of people, if they grow up with plants where they have early exposure to nature, it can give people the potential passion or plant heart when they grow up. That's how I feel like that. So, in terms of the plant and pest, can you tell us what's your favorite insect and give us the reason why? Like, because I am a plant person, I can give you a list of plants that I love, but not specifically for pest.
Right. So being from Wisconsin, I grew up in an area that was pretty heavy apple production. And I remember going in the fall to pick apples. And one of the things that I would always see is these fruit flies that were on the apples. And they were always very beautiful with brightly colored wings and interesting patterns. And today I know that those are tephritid fruit flies. Every species is bright and colorful and has interesting coloration patterns. And, there's some really nasty ones out there like Mediterranean fruit fly, which is always something the USDA is trying to prevent from entering the US. And there's other ones like the olive fruit fly, which is already in the US and devastating the California olive production. They have really interesting behaviors and they tend to hang around large fruits, so they're pretty conspicuous. That's something that stands out to me that I remember very young.
Okay, so basically, you kind of carried your passion for insects from your childhood all the way till now. What is your favorite plant?
So that would be lilacs. And the reason for that is my grandmother had a patio and it was completely surrounded by lilacs. I can just remember how that smelled in the spring. It was amazing. And that was a very special memory for me.
So, do you know, as a plant person, I like to throw out some information about lilac. The scientific name of lilac, it's actually named after a Greek nymphs syringa. So basically, the story behind lilac or syringa is because this nymph is trying to escape from the god, which named Pan, and then who is pursuing her, according to the story. And then to escape from his pursuing, and she turned herself to lilac shrub. And then the god found the shrubs and used its hollow roots to make the first pine pipe, the pine flute. Because a lot of times lilac is the first flowering or bloom in the spring, it also represents the arrival of spring and new life, and also the first emotion of love. Well, at least in Europe and England. So I guess this would be some conversation you might want to ask your mom. I think she might be interested in romantic or cultural and historical informations like this. Well, every time we go out and see a plant, you're like, oh, it's a yellow plant, it's a red color flower and all that, but there's a lot of information and stories behind the plant itself. So that's one of the things that I want to share with you all today. If you have a favorite plant, Google it or do a little bit more research on that, and you'll find a lot more meaning behind the plant itself. And I don't know if anyone out there has read the book. It's called Lilac Girls. And if you haven't, do it because that's one of the remarkable books that I read this year. The lilac as a plant, it's set in the front garden of the house where the lilac girls shares. Of course, the book doesn't have to do with the lilac plant itself. It's just something I would recommend you to read. Anyhow, back to the point with our main topic today. In agriculture or in academia, there are a lot of abbreviation of certain terms that we normally use, but maybe other people, when they first get introduced to some of those abbreviation we're using, they may not know what it is. So can you tell us, well, what it is, IPM, and just to give a brief introduction of IPM?
Sure. So IPM stands for Integrated Pest Management. A lot of times we now use IPPM, which is Integrated Pest and Pathogen Management. But specifically for my career, I focus on pests. So IPM is basically a science-based decision support system, which essentially aims to reduce the use of plant protection products, levels that are economically sustainable and that are safe for the environment and human health. IPM is sort of a group of different tactics that we try to utilize as a whole to create a program. We call that an IPM program that will ultimately help us achieve that goal of relying less on, broad spectrum insecticides, for example.
Mm. And for a lot of people, when we talk about IPM, the P, the past, people would tend to interpret it as past. It's kind of narrowed down to past only, but can you give us a definition of the past? What is the past we're referring here?
Sure. So when I typically talk about pests, I'm referring to arthropod pests, which are both insects, and mites, which are arachnids. Those are what my focus are. But at the same time, when you're managing pests, you're often also managing diseases because insects vector plant pathogens, and you're trying to kill two birds with one stone in that case to prevent plant diseases, any sort of damage that's actually due to the insects themselves feeding on those plants. And simply put, a pest is something that you don't want around that's causing you some sort of economic damage to your crop.
So, under that umbrella, I would say since pest refers to anything that people don't want, does that also include weeds
Yes,
in that regards?
absolutely. Weeds are definitely pests. They're unwanted organisms, and their presence can often lead to reduced yields in your crop, depending on where they are, particularly in field crops where they're directly in the soil with your crop competing for those resources. But even in a greenhouse, they can be pests because they can harbor unwanted insects on them that might not be in there if you only have the crop, and they could also be competing for light in your greenhouse as well.
Yeah, I think that's one of the things. A lot of times people are just like, oh, those are just weeds. They're only gonna compete in the nutrients in the water for the plant in itself. But in the meantime, they're also providing the habitats for those pests to get into the greenhouse or get into your crops, right? I know IPM involves a lot of steps. It's not an easy task for people to adapt. Can you tell us a little bit more about why people need to adapt it to IPM practices in their production?
Right. So, as I mentioned, the ultimate goal is to enhance sustainability and reduce risks from pests. And you're right, there's a lot of pros and cons associated with IPM. And I can go both those pros and cons if you like. One of the pros of IPM is that we're ultimately trying to use less pesticides, right? Pesticides have a couple different categories. I often break those down into biorational pesticides, targeted pesticides, and broad spectrum pesticides. The ones that we're mostly concerned about are those synthetic broad spectrum insecticides, because those really can damage the environment and have much higher risk to human health. Everything we're doing is ultimately trying to lower that. And the use of pesticides themselves, they can cause complications. One of the problems with using pesticides is it damages soil health. If you go to any grower meetings or speak with growers, one of the really hot topics these days is soil health and beneficial microorganisms. Often the things that we're either drenching into our pot media or spraying on the plant, which leads into the soil, is killing those microbes and denying the plant anything that you might benefit from that, right?
So,
probably hear about is, pesticide resistance. And when we use chemical pesticides over and over again, insects reproduce extremely rapidly. Often there's hundreds of thousands of individuals that can produce over sometimes 10 to 12 generations a year, depending on how warm the climate is. That just allows for very rapid evolving of resistance to different active ingredients that are in pesticides. Over reliance on those active ingredients can breed resistance, which can eliminate anything that's effective there for controlling pests.
I'm glad that you mentioned about the development of pest resistant to some of the chemicals that they're spraying for over and over applications. So basically, if people want to slow down the process of resistant development, what kind of things that you would recommend them doing?
Sure. Assuming that we're at the point we actually have to use these chemicals, one of the primary tactics that we utilize to prevent insect developing resistance to these is through rotating products, right? So there's dozens of different products that are effective against a particular pest. And often these chemical companies are developing these products in ways that they affect the pests in different ways, like either chemically or interacts with a certain system function. It can destroy the gut, it can prevent them from feeding, it can be a nerve agent, etc. So there's a group called the Insecticide Resistance Action Committee, or also known as IRAC, and they categorize all the different pesticides based on their mode of action and how they're killing that pest or affecting that pest's physiology. And you can look either on the pesticide label, often it will say what mode of action that pesticide is, or you can go online and see what it is. And you should always try to use, if you're using multiple products, rotating those products with different modes of action. And the other thing is always use maximum label rates if possible, because if you use something that's too weak, that allows more of the population to survive. And when more of that population survives, there's a higher chance that they contain a gene that can develop resistance there.
No, the disciplines that involved with IPM would be horticulture, entomology, plant pathology, and weed science. But what are the specific tactics that is involved in the IPM?
Sure. I like to think of IPM as sort of the food pyramid that we all learned. So looking from the pyramid, at the base of that pyramid is prevention tactics. They often say prevention's the best medicine, right? It helps you deal with problems before they even arise, which will ultimately save you money, not having to deal with the problems in the first place. Things like that can involve crop rotation. In the case of greenhouses, that's planting different things at different times of the year. You don't always have the same crop in the same greenhouse all the time, because a certain crop might be suitable for a particular pest. And if it's always there, their population can continually build up. But if you remove that crop and they don't have access to it, then it'll eventually die out and the greenhouse will clean out of that pest. Using resistant varieties. So in ornamentals and vegetables, the plant breeders spend a lot of time looking at how certain varieties are susceptible to different pests feeding and whether or not they get less or more damage. So using varieties that are known to be resistant against something that you have a problem with frequently can save you time. They either don't get damaged at all or they get damaged less to the point that the damage is below any threshold you actually have to treat for. And then, so that's the base, is prevention. The next step up from that is detection tactics. So after we've tried to prevent things, now we need to be monitoring for those problems to make sure that we catch them really early on before they become a problem and we start experiencing crop losses. For insects, that can involve a lot of things, but they generally fall under the same concept, what we call scouting. So we need to be out scouting the crop for issues. Generally, that involves walking through the crop and looking at it pretty thoroughly, and then taking notes on the issues we're seeing, where are those issues in the facility, when do they typically occur throughout the year. So if you're doing this, year in, year out, You can have some sort of level of predictability when problems are going to happen, so you can be extra attentive to that. And then we can use, so that's kind of active scouting. We can also use passive scouting methods, such as insect sticky traps that we would hang in a greenhouse that are attractive visually to these insects. They're going to fly to this trap, get caught, and we can look at these weekly and see if we're seeing any individuals. That's sort of a passive method. So active scouting and passive scouting are key detection methods. So now let's pretend that our prevention and our detection methods have failed. We now have pests that we have to deal with. Now we fall into the control section of IPM. And within the control section, that broadly falls into 3 categories: cultural control and mechanical control, biological control, and then chemical control, right? So cultural and mechanical control is things like sanitation, pruning, just things that humans are involved in that they can be active measures of prevention. So not going into the greenhouse, wearing your street clothes, for example, wearing gloves to handle crops, and then throwing those gloves out so you're not spreading pests and disease. So those are some examples of cultural control and mechanical control. Biological control, which we'll talk about a little bit more in depth, is using living organisms to control pests. And we've already sort of touched on chemical control. And I mentioned broad spectrum insecticides, targeted insecticides, and then sort of biorational insecticides within there. So that's the category you ultimately are trying to not to have to get to.
Well, thank you for the very surreal description or explanation of the IPM. You basically kind of draw the big picture for us as a pyramid, which has 3 layers, and also kind of give us idea of some of the steps that if people wants to adapt to IPM practices. First, you need the prevention, which is the first leisure. You want to start with clean materials and know how to grow good plants in the right place. And then from there, we goes up to the second leisure, which is prediction. So that's when you have to constantly go look and check your plants just so to make sure your plants are doing well. If you detect any potential symptoms of issue, react, take actions early. And then the last one would be the control part, the third level of the pyramid. That's when you have to make a decision of control the pest. Along that way, we have 3 different control methods, including cultural control, biological control, and chemical control. Well, chemical control, we kind of basically already touched based on just use pesticides and insecticides. Cultural control, it's kind of similar to the prevention part where you use tactics to help reduce the spread of the pest or the damage of the pest. But do you categorize banker crops and trap plants as cultural control, or it's more like biological control? And what is the banker crops and trap crops and how they work, so that we can kind of draw the line of if this is belong to cultural practice or biological control practice.
Right. So you mentioned banker plants and trap crops. I should first define what that means for our listeners. So a banker plant is typically a non-crop plant that you're placing either within the crop or adjacent to the crop. And that banker plant is targeting what we call either natural enemies or biological control agents. And those are organisms that we're releasing into the crop to help control the pests. And those sort of fall into a couple broad categories: predators, which are, preying on the pest; parasitoids or parasites, which kill the pests by laying their eggs inside them, and then their young eat the inside of the pest. And then things like entomopathogenic fungi and entomopathogenic nematodes are kind of a mix between predator. So the banker plants are targeting the pests through the natural enemies. On the other hand, trap crops, so those are a crop or a plant that you're putting into the crop. It's not the same thing as the crop, but they're typically a plant that is more attractive to the pests than the actual crop is. The theory there is that they're going to prefer being on that plant instead of the crop. So that is a plant that's interacting with the pest directly. So you asked me whether or not I thought that was more of a cultural control tactic or a biological control tactic. I feel it depends on if it's the trap crop or banker plant. Trap crop, I feel, is much more of a cultural control tactic. A banker plant is more of a biological control tactic. And an example of a trap crop we might use would be sweet alyssum, an example of a pest that likes thrips. So we have thrips in your impatiens, for example. They're going to want to be in your trap crop more than they are in your impatiens. And once they're in the trap crop, you can either spray that trap crop with insecticides so you're not spraying the crop itself, or you can physically take that trap crop out and destroy it, either through burning it or mulching it.
So if I'm understanding it right, so I'm just giving a real live example of the trap plants. Basically, for instance, if you want to protect your other plants from deer in your front yard, and I know there are a lot of deer loving plants out there, pansy is one of them. So for instance, let's say if you want to protect your eggplant from deer and you plant the outside circle of pansy plant so that the deer will chew on the pansy plant instead of the eggplant. So in that way, you kind of protect your eggplant from being eaten by the deer. Am I understanding it right?
That analogy is correct.
Can you give us a little bit more information on that? In ornamental, we're dealing with thousands of different plants. What are the challenges for ornamental crops and for growers to use IPM?
Right. So I guess I'll start out with talking about specific challenges associated with ornamental IPM. And at the same time, I talked about the pros of IPM, but I'll also touch on some of the cons I didn't get to mention. So ornamental crop production, you can think of that as crops that are either grown in a nursery setting or those that are grown in a greenhouse. They're mainly grown for aesthetic purposes, right? We're looking for something attractive for our landscape or our house that is pretty. So floriculture and nursery products are very susceptible to having their aesthetic value damaged by pests. So there's a very low tolerance for pests in ornamentals that we might not have such a low tolerance level in another crop where we don't care about how they look, right? So people that are growing ornamentals might have to use much stronger tactics to keep those pest levels down to such low levels that they're not damaging how that plant looks, right? The other thing is, so imagine you're going to your local nursery, right? As soon as you walk into the nursery center, you're bombarded with hundreds of different plants. Unlike field production, which might be a monoculture, meaning that there's just one crop grown over a huge amount of acreage, right? In ornamental or greenhouse production, you have a ton of different plants grown in a very small space. And that just creates complexity. And so you might have to use many different tactics in that very small space. And it can get complicated very fast. You can have a lot of different pests in a small area, which requires a lot of different management tactics in a small area. And finally, this isn't necessarily for nurseries, but for greenhouses. These are semi-closed facilities, right? They are structures that are more difficult for insects to pass through than they would be in an open environment. For biological control, we're typically releasing those organisms into the greenhouse and they're feeding on that pest population. If it's a good natural enemy, they're going to reduce that pest population to very low levels. What happens when a predator reduces their prey to low levels? They typically either have to migrate to find another place that has prey or they're going to starve. And inside a greenhouse facility, they don't really have that opportunity to go find more food. So oftentimes the natural enemies we're using in those facilities, their populations collapse and the growers are going to have to buy those products over and over again every time that they wipe out the pests, which can be a little bit expensive. So I mentioned I wanted to also talk about some of the cons of IPM. So that's one of the things is it can be expensive. IPM versus chemical control measures. Some studies have found that it can cost as little as 20% more than traditional pest management. So often IPM is more expensive than typical insecticide use.
Yeah.
The IPM pyramid, it is technically complex, right? And it's difficult to implement. And a grower is constantly going to have to learn and spend time learning about new methods that might be a better tactic to use in their IPM program. So it's much more hands-on and involved than just spraying a broad spectrum insecticide. And the other thing we kind of touched on is for an IPM program, you have to monitor it much more frequently to make sure it's working than you would have to if you're just spraying pesticides.
Yeah, I agree with that. But one of the things that I want to put out there is, well, you would typically think about, oh, IPM might be a little bit more expensive, but it really depends on the lifespan or the time period that you're evaluating the program. So I think it's just a matter of time, especially with the challenges we're facing in terms of pesticides resistant development and then the increasing concerning with environment leaching and pesticide contamination and all that. That's another reason why we're trying to, hopefully people are going to adapt to the IPM a little bit more. Again, you have to kind of do the math and say if you're going to buy a biocontrol agent and use it to manage 3 different hard to control pests for your operation, and you kind of have to do the math and say, okay, this is how much I put in to buy the biological control agent, and this is how much I can save from the damage caused by the pest I'm going to control with that. And also do a math with if you're going to just spray the chemical and then just do a comparison, then make the decision of which one you would choose. And oftentimes people are, based on the conversations that I had with a lot of different growers, oftentimes they find the biological control agent will give them better control effects economically in the long run. So back to the biocontrol, I know that you have done a lot of research on biocontrol, especially here in UJ in your lab. You are primarily working on biocontrol. Can you give us 1 or 2 examples of the biocontrol for specific pests where your lab has worked on?
Sure. I'll use 2 pests as an example just because they have a variety of different natural enemies available for them, and they're extremely important pests in ornamental production. The first is the sweet potato whitefly. The scientific name is Bemisia debassi. It's a really devastating pest of both field production and ornamentals. It's an insect that damages plants by feeding on the sap of the plant. We have a lot of different options to that pest with biological control. So the first things that were really developed for that pest were back in the early 1920s, and that was the parasitoid wasp called Incarcia formosa. Parasitoid wasps essentially function by walking across the leaf. They encounter the pest and then they basically sting that pest and lay an egg inside of it. And then their young kills that individual pest as it grows into an adult. And then that adult emerges from the body of that pest when it's time. There's a variety of different parasitoid wasps that are available. I mentioned Incarcia formosa. Other ones that are really good are Erich species. Both of those are commercially available for growers to use. We typically recommend that they use both Erich and Incarcia because whenever whitefly is present in the greenhouse, you typically have a couple different species, and those 2 parasitoids work better on some whiteflies and worse on the others. So most of the time, the commercial suppliers give you a mix of those. So in addition to parasitoids, we also have predators for those. And for whiteflies, we have predatory beetles in the family Coccinellidae. And the beetles that work really well for those are specialists, meaning that they really only feed on whiteflies and not other types of insects. That particular group of beetles is in the genus Delphastus. And the species that's commercially available for whiteflies is called Delphastus catalinae. Here in the South, we also have native species that work even better that might find their way into your greenhouse if they're around. And then we also have predatory bugs, such as Aureus insidiosus, that will feed on the whiteflies. So parasitoids and predators are the 2 main groups we have for whiteflies. Now, for thrips, the main thrips problem globally, as well as the US, is Western flower thrips, Frankliniella, and that is a really nasty thrips that devastates ornamentals. For that, we have a large variety of natural enemies as well, but those all fall really within the predator category. There's not really parasitoids available for that, but we have, like I mentioned, the predatory bugs. Aureus work really well on those. Unlike the whiteflies, we also have predatory mites, which are little mites that feed on other insects. The ones that work really well for that, for example, would be Emlisea swirsky, an example of a species that's commercially available for thrips.
Okay, thank you for the information just for those two pests. So there's one thing that I was thinking maybe some other people are also interested in for chemical applications. A lot of people would go look for broader spectrum chemicals, which means one chemical can be effective to control many different pest issues, right? Are there any commercially available biocontrol agents that would be considered broad spectrum, which means one bio agent can help protect or control many different pests in their production?
Not in the sense that there's something that controls everything, but we have options that control a lot. And I mentioned some of those. A Swirsky, for example, is going to feed on a variety of different thrips, a variety of different whiteflies, but it's also going to feed on spider mites, for example, which we didn't touch on. It's a generalist.
Only this one? So it's different like the chemical that we're using, where one chemical has, well, I wouldn't say everything, but a big range of different pests, right? So basically, in the biocontrol world, we only have one of those
Well,
that has potential to control various pests.
no, I kind of touched on one I already mentioned, and another one would be Aureus, which will feed on a whole bunch of things as well. But yeah, between the mites and the predatory bugs, those are our most general natural enemies we have. But those will not really help us with mealybugs, for example. They won't help us with scales. They won't help us with fungus gnat. So there's a bunch of pests still that we have to have other options for that they won't take care of for us. So yeah, there's no magic bullet that deals with every single pest out there.
Oh, okay. So I guess that's another reason why we need IPM, which involves a lot of different tactics to control those pests because only a certain of pests can be managed by one set of tactics. So as a IPM or entomologist, can you give us some suggestions in how to develop a successful IPM program?
Sure. Before I answer that question, I wanted to touch on the other spectrum, which you asked about generalists, but on the specialist side, we have tons of options there. And often we use specialist biocontrol agents because specialists often are more effective than generalists for trying to control a very specific pest. So we might not have a natural enemy that controls everything, but we do have natural enemies that are control one thing and they do it very well. I just wanted to say that before we move on. Now, you asked me about how would I recommend setting up a effective IPM strategy. Well, the first thing, as I mentioned, one of the difficulties in IPM is it does require knowledge and it does require some technical expertise. So every grower, in order to really be successful in IPM, needs to take time to educate themselves on what the options are and how they work, right? That is really the basic first step is education, right? If you're educated on what's going on, you'll be successful in your pest management strategies. So that being said, you should have employees that are also knowledgeable, and they're the ones that are going to be out in the front lines, working in your crop, looking at it all the time. If they don't know what they're looking for and don't know how to properly document problems, your whole IPM pyramid is going to basically collapse. You need educated yourself and your skilled workers that's your first basic step to being successful in IPM is know your production and where the risks are. So when I say risks, where are parts of the facility where insects can enter, or where are the crops that are most susceptible to pests located. If you know where you have the most risks, you should be spending the majority of your time monitoring those areas that are high risk, because that's the most efficient use of your time. Know your risks and know your operation is the second step of being successful. And the third step is diligence, right? Don't just scout once during a crop cycle for pests. Be out there weekly looking for pests, or bi-weekly, whatever you have the labor for. The more detection and prevention that you're doing, the greater the likelihood is that you're going to find something before it becomes a problem. And then finally,
Yeah, you're
I think
right.
the last component to be successful in IPM is patience, right? One of the cons of IPM is it's going to take longer to work typically than chemical pesticides, and a grower has to be patient enough to let IPM work.
Yeah, it's not just for the IPM to work, basically for a lot of things in life. You kind of have to wait and see if this works, if not, and then make the decision if you're going to this route or just change your journey to another different direction. What are some of your next steps that you're excited about of the IPM in your lab in general, and that can help with our industry, with our grower, and in their production?
My lab, we have a big focus on biological control, but that's not all we do. Part of my program is trying to understand what works and what doesn't work from our standard playbook that we have for pest control from what we've researched on ornamental production. So I focus a lot on the new technologies that we use in these facilities, such as LED lighting, supplemental LED lighting production, nanobubble technology, which creating higher oxygen level environments for enhanced crop growth. One of the things we didn't talk about much was pathogenic nematodes, which we're typically applying through irrigation or drenching our crops. How do they interact with higher oxygen level environments? Does that increase their efficacy? I mentioned lighting, very interested in how that interacts with pests, since insects' behavior is so driven by different lighting quality, spectrum, intensity, etc. Understanding the barriers to some of the more advanced production, hydroponic growing facilities, vertical farm growing facilities. How does that impact the movement of insects, and ultimately how we manage them in those really complex growing situations?
Yeah. So with that in mind, if people wants to look for more of what you do and some of your work, where do you recommend they go to look for?
Sure. So I'm on LinkedIn. You can find me, Erich Schoeller. I also have a website, which is schoellerlab.caes.uga.edu, where I post what I'm doing, and I've got my contact information on there as well. You can go to the Department of Entomology and see my faculty profile. My email is available there as well.
All right. Thank you so much for sharing your experience and stories with us today. And again, you're always welcome back to talk more about your research. Thank you again for this wonderful episode for IPM. Thank you.
Thanks for having me.
If you're looking for more information on IPM, AFE provides additional resources. First, go to sustainabloom.org/industry guide/IPM. Second, you can go to endowment.org/TB. This website also provides you guidance on building IPM program, as well as resources for thrips and botrytis. To save you time, I will place all those links in the show notes. This episode in our first season is made possible through an educational grant from the American Floral Endowment, whose research priority helped shape the topics that are featured. To learn more about AFE and access their research and educational resources, visit their website at endowment.org. Conversation like this only happens when you support the show. For more information and find ways to support us, please go to bnbpod.com, bnbpod.com. If you like what you are hearing, spread the word and share this podcast with the people you love. Make sure you hit that subscription button and give a review for the podcast. And as always, go check out the show notes to learn more about this topic and other topics we featured on the show at bnbpod.com. Thank you for listening. Till the next time, stay healthy and go plants.